So, okay, so while this setting up, I want to thank Professor about EC, you mentioned about EC, and I want to tell from the field because the Gluster file system already supports EC from last 1 year, and we are seeing a lot of success stories from the field. So if you are trying to use something in the similar lines, you want to experiment more, I like contributions. It is open source. You can join the community, try it out, and try to see what is there in more in EC and contribute more. Okay. So today I'll be talking a little bit about software-defined storage, what it is, why it will be relevant, as in while the storage is growing leaps and bounds, right? So let's look into why mostly the audience in this room, right? So why we should be caring about software-defined storage. So first thing, some of this is dark. The slides may be, as they said, it will be available later, so you can check it properly. Okay, so I should have used the white background. So I'll read it out. So the first thing you should be caring, because storage is a significant chunk in your IT budget. So if you are setting up a large project, large company, storage eats up some budget, right? So it is after your servers and network budget, storage is the next budget. So you should be mostly caring. And it is growing at really high percentage. We at least estimate it to be around 40% year-on-year growth. So, each one of us contributing for it, right? So we generate so much digital data, but the point is storage is growing at 40% year-on-year. So you would be caring about it. And as I said, yeah, it is part of top 3 of your infrastructure budget. Now, considering it is a developer conference, right? So why you should care more is because storage is changing. It is not anymore same or like the traditional way. So there is not just one standard which will say, okay, this standard would stick for next 20 years or 100 years, right? So it is changing because the data is changing in the way, the size of data, the type of data, and all of that. And what we are seeing is the more traditional or the long, like old, okay, you have a storage disk block, magnetic disk, and you get an operating system on top of it. That part is changing. So the applications layer is changing rapidly. So the storage layer has to catch up with it. It has to provide justice to the speed expected, the management layer, right? So what are the features expected from the application layer? And there is a lot of changes in these lines. So we are seeing a huge difference here, and I believe that is the reason why all of you should be caring about software-defined storage. Now, let's look into some of the current trends in the data and the storage world. So there is a data explosion in terms of how much data we generate in terms of mobile, web, social media, cloud, and things like that, right? So if you look at the companies like YouTube or Facebook or Netflix, look at the amount of data they would be generating every day. It is huge. So next, media and entertainment. So the number of TV channels are increasing. So you would be seeing, okay, so we launched Republic recently, right? So it is like more channels are launched. The way they conduct their programs is changing. It is all digital now. So say, look at maybe a film from animated movie, right? So maybe 8 years back, and I was talking to one of the larger the media groups. I was talking to an engineer there. So he was mentioning to create a film, something, let's take an example of Up or Valley type of films, right? So they generate 300 terabytes of raw data and would process it later and would get back to 1 terabyte of actually presentable film. So it's like 300 terabytes for a movie. So that is 1.5 hours. So that much data is generated from the media houses. And just one movie I'm talking, and every year there are so many movies made, right? And not just movies, the number of sports event, say, for example, SDC decided to stream this event. So we are generating a lot of data here. So next, video on demand. So it is already a household name in US, like Netflix or Hulu or a lot of other services are default. In India, it is picking up. Mostly, most of us would be having subscription in like Netflix or Hotstar or like many of the other things, right? Airtel movies or whatnot. So the on-demand, video on-demand services are increasing. People are paying for the service, so that means the expectations are different. So it has to be available. It is like, oh, you need a higher quality. I got a HD or Ultra HD or now Super Ultra HD, something like that, right? So the quality of streaming has to be awesome. So that means the speed of the extraction to the amount of data stored is a lot. As people said, yeah, so now there are so many more applications, so many more, say, let's pick up IoT or other things, right? So we are actually leaving a lot of digital footprint. So what it means is the analytics which is tracking the event, what is generated from all these devices is a lot. So we are creating a lot and lot of data. So what is the impact of all this? So yes, we all agree we are creating data, right? So what is the impact? Let's look at the challenges. So the exponential growth of data is putting a lot of pressure on capacity of the storage, the scalability of the storage. Oh, I bought some 100 terabytes of storage, right? So from some company. Now that you would overrun in no time. I mean, if you're in some of those domains, of course. As an individual user, I may, like 4 terabytes I have as a home system is good enough mostly, but as a company, the 100 terabyte would be like gone in some time. So, and cost, of course, as a company I have to be, and in the times, difficult times I would say, we should be aware of cost, but because we are in the business, we can't be letting go of the storage also, right? So it is an important part of your infrastructure. So all of these are increasing. Next, expectation from the storage or data is high. We have multiple devices. We expect data to be available all the time. We want internet, okay. So the expectation is more. It has to be agile. So it should be available everywhere. It should be fast. We are going patience. I mean, our patience level is reducing, right? So we had 3G, now 4G, and it's like, oh, if I don't see the video immediately, I would close it and like move to something else. So that is the expectation of the users. So we need agility with the storage, right? Next, it is not enough to be saying, okay, we are an on-premise. So the expectation is, I have some data center here, but it's not enough. I want to back it up in the cloud. So the data is now residing everywhere. It has to be on-premise, it has to be in the cloud. So the expectation of storage is, okay, you take care of all of this. So can you? So it has to be flexible. Next, as people are talking, right? So the security of the data is, we have all agreed that, okay, the companies or all this, I install an application in my phone, I know that it's capturing every movement of me, right? So it would know my location and whatnot, all of this, but we are trusting that they have some security of my data. So as a storage vendors, I believe it also is important for us to have that security enabled. So all of these are challenges of more data being generated. So now, yeah, I don't think a lot of people are seeing it. It's a big fish here, and there are a lot of fishes. So, but the point is, yeah, flexibility is important. So if it is one big fish, I believe, yeah, it can swim, no doubt, but with the flexibility, they can turn faster, they can change directions and whatnot, and they will be better. And they can survive even with some smaller things going down. Cool. So let's look into now. I talked about the situation mostly and the pressure we have as a storage developers and the companies. So let's look at what is software-defined storage, how it would be relevant, right? Okay. So this is how most of us studied storage or imagined storage long back, right? So you are a user, you want data, you have some box, either it may be a disk or something. So you start storing your data, extracting your data from there. So you overrun that, okay, you buy something else, keep it, and start using that. So it is, for people's reference, sorry about the lines, it was not darker. It is multiple boxes here, if you see. So each user is accessing their own boxes, their own thing. So there are multiple users. So they would be accessing mostly different appliances. Now, what happens in software-defined storage is all of this data, or the users, right, are talking to one layer, regardless of where they are coming from or what they want to access. They talk to the software layer, which is defining the policies for this storage, where it is, and all of that. Like, for example, erasure coding, right? So if we have that, the software layer is taking care. It is deciding, okay, this data bit, this block is residing here. Go there and fetch it. So things like that. So underneath the software is where you put general, or what do you say, the commodity hardware. You can scale it out and things like that. So this whole block can be a cluster of a lot of storage and servers, right? So this is at the top level, what is software-defined storage. What it does internally, what do you mean by the policies? Yes, that is where a lot of developments are happening. We are still evolving there. That is an evolving field, I would say. And okay, so this has become a lot of dark. But yeah, the point is software-defined storage scales better. The top picture talks about a smaller box which says storage appliance and a compute nodes on top of it, right? So if you want to enable cloud there, so you have a fixed appliance which can host, say, so many clouds only, right? So only so many VMs. Now, with software-defined storage, you have more nodes here. If you want to scale the compute nodes, which users are seeing, you just increase your the bottom storage nodes so that, oh, okay, you now have more capacity. You can actually increase the computing nodes. So it becomes more flexible for you. So or not. So the flexibility, as I said, is a need of the hour. Okay, so why are we bothering about it, right? So first thing, we are seeing a trend. Earlier, it was customized hardware, like a proprietary hardware, which was, oh, well done for your application. Okay, you have a database, awesome. So this box works great for you. So you take it, right? So that type of situation, now we have moved to more of common off-the-shelf hardware, because as a company, I don't want to invest to that big, the box size, whatever, it looks similar to something which I can buy in the SP road, right? So things like that. So why should I be paying a lot? So that type of questions people are asking, and hence the storage industry is changing. So it is like, why can't I use the same hardware? I would buy a disk from different vendors. I can build my own system. Why can't I use it? So that questions are coming. So what happens with this is, yes, customers or end users can reduce their cost. Yes, cost is a key thing. Next, they can work with a similar supply chain and things like that. Next thing to bother about here is, earlier it was a scale-up architecture, right? So there was a lot of investment which went into, okay, I want to increase the density of the media. I want to increase, okay, what can get into the machine. So earlier, okay, you had, say, 100 GB disk, then became, okay, 500 GB, then 1 terabyte, 2 terabyte, 4 terabyte. Now 10 terabyte is common. So that is a scale-up part. So now, the earlier, what customers were buying, one machine, one appliance, was like, okay, 16 terabyte, okay, that is the limit. 32 terabyte, okay, 64, 128, things like that. But the software-defined storage has changed it to scale out. Oh, you want more? There is no limit. You can go to petabytes, exabytes. Now, you want to increase? Start less, grow as you need it. So that is what is happening with the scale-out architectures. So what happens with this is, as a company, as a smaller team, you can start with less. You can plan your design everything right. Start with lesser cost, lesser money, and go to grow it later when the need is. So earlier, for example, right, we talked about, how the intelligence was in the hardware layer, like RAID or the hard disk itself deciding, okay, this block should be closer, or all of that. So it was all device drivers writing all of this, and the intelligence was there. Now, what is happening is, the intelligence is moving to software layer slowly. So software is deciding, okay, you are expecting this block, okay, I'll give it you from there. So you don't bother. So you can store it as you need. So, okay, you take this block, things like that, right? So this is another thing why we should be looking at software-defined storage. And with this, what happens is we can experiment quick, we can bring changes faster, and it will help the programmability. Okay. So earlier, again, what I'm talking about is the development process was pretty key as an industry itself, right? So we were very keen on keeping our own patents, our own ideas to us so that we can make money. But now what is happening is we want collaborative effect to bring the changes. The change is like, it's not enough. I mean, investing into something as big as storage is not possible to bring new change if everybody works in silos. We can bring change only if we can work together with a lot of investment going together. We can bring a lot of change in the whole, what do you say, domain, storage domain, I would say. So that has changed into more of open development process. With that, there is, like, for example, SNIA to exist, right? So it has to define, okay, this is a standard. So that can come when we can collaborate and say that, okay, this works for us, all of us. So things like that. Cool. So how would things going forward? What are the challenges, right? So let's look into some of the things. Oh, okay. Sorry about all of this. So what we are saying here is today, the major things which are already established, which are decently consuming the storage is cloud and object storage. What is emerging as analytics, as in big data, it is still emerging, as in it's not done yet. The hyperconvergence, what it means is, okay, I have a storage, it also has a compute, right? So it is not just a magnetic data which is sitting there. It needs to have a CPU to put in data, read data, and things like that. Why can't I use that CPU for my application? It is idle most of the time. So the question is, okay, you can. So now it means it has to be hyperconverged. What it means is you can run your application on the storage. So you save the cost on the overall nodes and things like that. So that is picking up. So we are seeing some traction there. And containers, microservices, right? So all of that is picking up. So cloud, VM, those things are already proven. They are using it. Containers, yes, it is using in a big scale. So the last block is all question mark there. So we know that there is a long way ahead, how people would be using. So that is what we are thinking a future. The moment there would be a new trend, it would need to process data, more data than whatever all of these are combining today. So that's what we are thinking, right? So this is mostly about the trends. And I'm not saying, okay, so this whole clustered or scale out way is the only way, right? So we have to find a balance here. So as an industry, we have to understand what we are all good at and what is the bucket where we can operate best for the maybe scale up model or things like that. So it actually, if you buy an appliance, yes, it may be much better for a durability. It may bring, okay, for your management, it may be easy because it is one box, it get all the monitoring you need and things like that. So we have to balance between our use cases and things like, okay, how each of these use cases fit well for each of these industries. So that's the challenge ahead of us. So we understanding ourselves, okay, we work really good on this because what we have seen is, I mean, from my own experience with cluster, right? So we started in 2006. So it was a user space file system. So it looked very easy, as in it looked, oh, user space, okay, kernel space, okay, it would be hard. But not really. So after 10, 11 years, we are still improving. We are still getting to a stability. The reason being, it is not, as I said, right, storage is changing. That is the first part, but it is a complex thing. We have to understand a use case properly. We have to, if we had focused our energy into certain use cases, maybe we would have matured much faster. But yeah, the point is, you never know. The point is, we have to keep growing. So the balance is very, very critical for the storage industry, in my opinion. So we are still figuring out which domain, which things work with software-defined storage versus the appliance model and things like that. And with the platforms like OpenShift or other things coming out, everybody has a play here because there is a use case for which some applications work better with the appliances. All of us can sit together, things like that, that exist. Now, we believe, software can be robust. Well, it is faster to change, so you may argue that there will be a lot of bugs, well, but we can fix it faster compared to a lot of hardware changes, right? So, but it can be deployed in a cloud or in the machine or even in your container. So that is a major flexibility software can bring you. Or it can programmatically shrink or grow. So the limit is, there is no limit, I would say. So the limit is your imagination here. So, I mean, it is true that with software, it is all about your imagination. You have your paper, you can bring in the concept to reality much faster. For example, erasure coding, right? So we were thinking about erasure coding in 2013. The concept was there, but by 2015, within 2 years, we had a production setup ready. So things like that. So it is much more faster development cycle with the software, and we are actually proof of it because from your concept to reality, even in the storage world where things move much slower because people want proven things, I would say, it is better. And it surely brings the operational efficiency. So the standardization of storage makes it so much easier for an admin to manage it. So, and it's like now with both like as admin can decide, okay, he needs more capacity. I don't need a lot of power. I'm just archiving a lot of data, right? I just write once and may not be reading more. So I just add a lot of disks to the same machine. I can do that. Or if I'm looking at performance, I can keep lesser storage per machine, put more CPU, put another node, so you get performance. Things like that. So it is evolving as we grow. So, and clusters can shrink because assume, I'm cutting cost, right? So I'm taking down so many users who are like all of this. You can shrink the cluster also. And you can decide based on your workload, based on your application, what type of storage I need or what type of cluster I need. Should it be throughput oriented? Is it about capacity? Is it about the performance? Things like that. And yeah, again, a rising tide is, again, there are years down there. There are numbers, even billions of dollars in there, which is growing in terms of what type of storage, like hyperconverged to object storage to file storage, the market segment. This is from an IDC survey, what we are seeing. So there is a statement made earlier that by 2020, there would be like 70% to 80% of the storage would be in the software layer, as in the policies, everything would be driven by that. And the prediction is even the existing storage at a product would be software layered by 2019. So that's the expectation from IDC. With that slide, mostly I'll conclude faster than expected, I guess. But I'm happy to take more questions if you have. And there are more data about software-defined storage at our site. You can check that out. And in Red Hat, there are two major software-defined storage products we work with. I work with Gluster as a manager and also partly developer. And we also have a Ceph team which works on the Ceph product. So anything you have, any questions on Gluster or Ceph, do reach out to me or us. So we have many of my team members and also Ceph team members here in the conference. Yeah, we are happy to help and get you initialized if you're looking at. Thank you. Any questions? Was I very fast or was I totally off the balance? I just want to get an idea. And I'm sorry about the slide background. So somehow it was not to the contrast. Yes, Brett.
So I mean, software-defined storage obviously it's happening. It has to happen.
Yeah.
The economics drive it.
Yeah.
I was kind of interested in, you talk about the path, the arc of Gluster. Ceph has a similar arc in terms of how long, who knew software-defined storage is hard.
Correct.
But the IDC prediction about how fast software-defined storage takes over the market. I mean, what's your sense on that? To me, that seems, it's obviously going to happen, but maybe that's quicker than,
So it is tricky. So first thing is the awareness, I would say, because end of the day, people who are writing checks may not be aware of a lot of these things. So that's what matters, because as I started with, right, storage is a bigger, the whole big part of the infrastructure. So if you look at a big company, enterprises, because the investment, lot of investment happens. I mean, for example, I started my company. For me, it was very easy decision. You get AWS or DigitalOcean or some of the other cloud where you can go and start putting your data. Then as you grow, if you have some business, you can think of other options. But as an enterprise, it is about awareness. It is about, have you proven things? And a lot of things make that decision. I think it is more sales driven. I can't comment on it because I can't sign checks. But the point is, I believe at least the prediction may be aggressive, but if there is a large cluster requirement with the data growth, how much is happening, there is no way, I would say, other than moving to scale out and like petabyte scale clusters. So because soon your data requirement will grow up, because assume if you are handling videos or other things, of course we are generating a lot of data. Even otherwise, the quality of imaging, for example, even if you are doing the satellite imaging or something, the earlier images to now, it is drastically different. So the type of images, the quality of number of pixels in the image, everything is increased. So I don't have a number on, okay, on this year, this will be 80%, right? So, but I see a major trend. I mean, if I just look at how both of our product, right, Gluster and Ceph is selling in the market, I see that trend is increasing. Yeah.
So I was going through Ceph, this one, erasure coding. So it used 16 node, right? 10 for data and 6 for parity for erasure coding. So since erasure coding add more performance bottleneck because it has to calculate the data from the 10. And it is more used in archived solutions rather than a block or file. So is there any solution like, for end user so that it can choose between erasure coding or traditional RAID? For example, it want to go for RAID 5 or RAID 6.
Okay. So I think Brett can talk more about Ceph, how it works. But with Gluster, how we normally sell it is, okay, you have different volume types which can coexist. So the way it works is, okay, if your application needs a faster access, it doesn't care because it's not like a lot of data, you use different type of volume on the same set of nodes. Whereas if you need a more of backup, because we don't want to invest a lot of money in the storage because I want to replicate the data 4x, right? So that is where we recommend using EC as in erasure coding. So yes, it is a challenge, but one of the models where it is supposedly working out for us is because all of this storage is in the separate layer, as in separate storage servers, right? So it depends on the CPU of those storage and all of that. So for an application, like if you're working on a container or something, right? So we are not seeing that huge performance hit yet because of erasure coding. So I would put it that way. Anything else you want to add? Yeah. Okay.
Thank you.